Hello friends, welcome to Namagiri's channel. In this video, I would like to present to you the proof of the fact that if a line makes angles alpha, beta and gamma with x, y and z axis respectively, then cos square alpha plus cos square beta plus cos square gamma equal to 1. And these are called direction cosines, these cos alpha, cos beta and cos alpha. We often read this in our books, but we generally don't ask how to prove this and why this is true. So let's take a peep into it. I have drawn here the diagram. Here L is the line that is passing through the origin. Now a line in the plane may not pass through the origin, but since all parallel lines have same direction cosines, we can always translate a line and let it pass through the origin, and therefore without the loss of generality we can assume that the line is passing through the origin. So I have taken here is the line that passes through the origin, and this makes angle here that is shown, the angle that it makes, angle gamma with z axis. All right. So this is our preparatory diagram. This is x axis, z axis, and this is the y axis, as you can see over here. Fine. So we shall first analyze the case of, we shall first see what cos of gamma is. Here I have shown only the angle gamma. The computations with the angle alpha and beta will be the same. But let us first understand what is happening when this line is making angle gamma with the z axis, and how the parameters, some parameters with line L are related to the angle gamma here. Now here this vector u is the unit vector that lies along the line L, and this is the projection of this vector u. This let this be let's say this be O, this is the origin, let this point be P, OP is the unit vector u along line L, and let this be, let's say, R. So PR is the projection of unit vector onto the xy plane, okay, and as a result, by definition of the z coordinate of a vector, this PR is the distance of the tip of this vector from the xy plane. So this is the z coordinate of this vector u. So let this vector u be x comma y comma z, and since this z denotes the distance between the tip of the vector and the xy plane, where this PR is the perpendicular drop from the tip to the xy plane, this is the z coordinate. All right. Now what can we observe about this z? This ORP is the right angle triangle, and here gamma is the angle that is made by vector u with z axis, and therefore this remaining angle, okay, that this makes this vector UP makes with this OP makes with OR is pi by 2 minus gamma. All right, because this whole angle is pi by 2. This is the z axis, and z axis makes angle pi by 2 with xy plane, and this is gamma. So this is the remaining angle, which is pi by 2 minus gamma. Now in this right angle triangle OPR, this ORP, angle ORP is the right angle triangle, angle ROP is pi by 2 minus gamma. All right. So in this right angle triangle, what can we say? Sine of pi over 2 minus gamma is equal to the opposite side, which is PR, length of PR, PR means length of PR, divided by the hypotenuse, and the hypotenuse is the OP. So that is OP. Let me write this as OP. But sine of pi by 2 minus an angle is cos of this angle. So this is cos of gamma is equal to, now this PR is the z coordinate, of vector u, and this OP is basically the length of vector u, but we have assumed that this is the unit vector lying along the line L, so therefore its magnitude is 1. So this is 1, which is z. Now we have come to this equation. Let's call this as equation 1. This is cos, so what we have obtained is cos of gamma is equal to z coordinate. So similarly we can write cos of alpha equal to x and cos of beta equal to y, where x and y are the coordinates of vector u. Now what do we have? By the formula for the length of the vector, we have x square plus y square plus z square equal to the length of the vector u, the square. This is what we know. Okay, now we can substitute for this x, y and z over here. So what we have as a result is, so I want to call this as 1, this is 2 and this is 3. So from equations 1 and 2 and 3 we have cos square of alpha plus cos square of beta plus cos square of gamma equal to, so here we have substituted for x, y and z using equations 1, 2 and 3, and the magnitude of u, the square, is 1, so 1, and that proves what we wish to prove. All right, so I will stop here. That is the end of this video. See you in the next video. Bye.